Here is the piece almost nobody connects, and it explains why this fight is bigger than one robot. NVIDIA's data center business alone reportedly generated around $75 billion in a single quarter, up 92% from the year before. That is the entire modern AI industry, concentrated inside massive, centralized data centers, sitting in buildings most of us will never see. Tesla's strategy is almost the exact opposite. Instead of concentrating intelligence in one place, it wants to push that intelligence outward, embedding it directly into cars and now into millions of walking, grasping, physical machines standing in your world. If that strategy works, every single Optimus unit stops being just a robot. It becomes what engineers call a physical AI endpoint, a machine that senses the real world, thinks about it locally, and acts on it immediately, without waiting on a distant data center to respond. Multiply that by 1 million robots, and you have 1 million physical AI systems operating at once, everywhere, simultaneously. Multiply it by 10 million, and you are no longer comparing this to anything the robotics industry has built before. You are comparing it to the moment smartphones went from a novelty in a few pockets to a device in nearly every hand on Earth, except this time, the device can lift boxes and eventually replace a shift. Picture the electricity bill of a small country, then imagine that same appetite for power distributed instead across parking lots, hospitals, and factory floors near you, one robot at a time. That is the actual shift happening underneath this story, moving the most expensive resource in modern computing out of a guarded building and into a machine standing a few feet from wherever you happen to be. It is a bet that intelligence belongs everywhere, not locked inside a server farm you will never visit or vote on. One robot learns, a million get smarter. Here is the part that should keep you up at night. Tesla's self-driving cars already do this at scale. Millions of vehicles on the road generate the equivalent of hundreds of years of driving experience every single day, and every mistake one car makes can be folded back into a software update pushed to the entire fleet overnight while you sleep. Now apply that exact same model to a body with hands. If a hypothetical fleet of 1 million Optimus units were active at once, the fleet would theoretically accumulate 1 million hours of real-world physical experience in a single hour of clock time. One robot drops something in a warehouse in Ohio. By morning, 1 million robots know not to make that mistake, from Texas to Tokyo, without a single meeting, memo, or training manual involved. If this data pipeline works the way the model suggests, the pace at which these machines accumulate experience could outstrip anything a human workforce has ever achieved, and it would not need sleep, turnover, sick days, or retirement to keep improving. Think about what took you decades to learn on the job. The instincts, the shortcuts, the muscle memory nobody could write down in a manual. A machine could absorb the equivalent of that overnight and never forget it, and never age out of the workforce the way a human eventually does. And unlike a human employee, this fleet never asks for a raise, never negotiates a contract, and never needs a retirement fund waiting for it after 40 years of service. That is not a hypothetical for your grandchildren's era. Based on the timeline the company itself has laid out, it is a hypothetical for this decade, arriving faster than most retirement plans were built to handle.